Hello friends, welcome to my channel. Today, we're focusing on K2-18b, one of the most exciting planets outside our solar system. We'll explore this world together, which is thought to carry water vapor and potential signs of life. This isn't science fiction, it's real data and current research. If you're ready, let's embark on a journey into the depths of space. Since the dawn of humanity, we have gazed at the endless expanse of the sky and asked that magical question: are we alone in the universe? The stars twinkling in the night sky, distant galaxies, and the cosmos filled with the unknown have always captivated our curiosity and ignited our imagination. Could there be other beings like us, capable of thinking, feeling, and living in this boundless universe? This question goes beyond mere curiosity. It reflects humanity's quest to understand its own existence, its place in the universe, and the meaning of life. As we journey through the depths of history, we see that different civilizations have sought answers to this question through their own cultural and philosophical traditions. From ancient Egypt to Mesopotamia, from Greek philosophers to medieval thinkers, many civilizations have associated celestial bodies with gods, mythological beings, or different life forms. These narratives contain an inner hope and curiosity that humanity is not alone in the universe. For example, the Greek philosopher Metrodorus, who lived in the 4th century BC, drew attention to this possibility by saying, "Just as it is meaningless to think of a wheat field in an infinite field producing only one grain, it is equally meaningless to think that only one world in an infinite universe harbors life." With the scientific revolution, our approach to this ancient question underwent a radical change. The invention of the telescope and advances in astronomy revealed that the universe is much larger and more complex than we had imagined. Mythological narratives have been replaced by scientific research based on observation and evidence. However, these scientific advances have not eliminated that fundamental question. On the contrary, they have deepened it and transformed it into concrete pursuits. Today, the field of science known as astrobiology is the most exciting manifestation of this ancient curiosity and quest in modern science. K2-18b was discovered in 2015 by NASA's Kepler Space Telescope when it detected a slight dimming caused by the planet passing in front of its star. It orbits K2-18, a cold dwarf star located approximately 124 light-years away in the constellation Leo. One of the key features that makes K2-18b so interesting is that it lies within its star's habitable zone. The habitable zone is the orbital band around a star where a planet's surface can have liquid water, meaning it's not too hot or too cold. Since liquid water is a fundamental requirement for life, as far as we know, planets in the habitable zone have always been a top priority for astrobiologists. K2-18b is approximately 8.6 times more massive than Earth and has a radius about 2.6 times that of Earth. With these characteristics, K2-18b falls into a category of planets classified as sub-Neptunes, or super-Earths, which have no known counterparts in our solar system. We know very little about the internal structure and atmospheric composition of such planets, making them both mysterious and scientifically highly intriguing. K2-18b's orbit around its star, or 1 year, lasts only 33 Earth days. While this means it orbits very close to its star, the fact that its star, K2-18, is a much dimmer and cooler dwarf star than our Sun allows the planet to remain within the habitable zone. However, being within the habitable zone does not automatically mean a planet can support life. Factors such as the planet's mass, radius, the presence and composition of its atmosphere, its internal structure, and geological activity all play a role in determining its actual habitability. K2-18b's mass and radius values suggest that it is more likely to be a Neptune-like gas giant, or a potential Hycean world, rather than an Earth-like rocky planet. This is where the story of K2-18b becomes even more intriguing. The presence of water vapor in the atmosphere does not necessarily mean that there are oceans. K2-18b may be a planet with a much thicker atmosphere, with its surface hidden beneath a layer of gas. However, the presence of water indicates that the lower layers of the planet's atmosphere may have the temperature and pressure conditions necessary for liquid water. For example, Venus also contains trace amounts of water vapor and acids in its atmosphere, but its surface is uninhabitable due to extreme temperatures. For K2-18b, the atmospheric pressure and temperature profile are still unclear. Therefore, it is currently difficult to definitively state how the vertical water cycle operates. Scientists suggest searching for gases like methane in addition to water in the atmosphere. Since methane is often associated with biological activity, the detection of both water and methane in the atmosphere could be a stronger indicator of potential signs of life. Observations planned for after 2020 with the James Webb Space Telescope aim to track such biosignatures. Between 2025 and 2030, we may be able to detect methane, ozone, or other trace gases in the atmosphere of K2-18b using telescopes like the JWST and Ariel, the European Space Agency's spectroscopy satellite. This would allow us to see the chemical footprint of life much more clearly. This is a step that will shape the future even before it begins. The planet's mass was determined to be approximately 8 Earth masses using the Doppler spectroscopy method. Since its radius is 2.6 Earth radii, its density is much lower than Earth's. This suggests that K2-18b is not a rocky planet, but may have a gaseous or liquid layer. Therefore, the concept of a surface may not be a liquid water ocean, but rather meteorological cloud layers and a high-pressure supercritical water region beneath them. The planet's core may be much larger than Earth's and composed of iron and nickel. Surrounding it may be an ocean of liquid water under high pressure. The atmosphere is so thick that when a certain pressure is reached, water will no longer be defined as a gas or liquid. It will become supercritical. This could accelerate chemical reactions and enable the existence of extreme life forms. K2-18b could also be a Uranus-Neptune class planet. In this case, discussing the surface would be meaningless, as the thick hydrogen-helium atmosphere prevents water droplets from forming. The planet receives approximately 10 to 15% more energy from its star than Earth does. This translates to an unstable temperature range of 325 to 350 Kelvin, approximately 50 to 77 degrees. However, if the atmosphere is thick, the pressure and greenhouse effect in the lower layers could cause surface temperatures to exceed those of Earth's hottest deserts. While this does not mean grilling temperatures, it is not outside the planet's habitable zone, as water and clouds in the atmosphere can redistribute heat, creating milder conditions in certain areas of the surface. On Earth, organisms known as extremophiles can survive in the hottest thermal pools, acidic lakes, and frozen tundras. If K2-18b has a temperate water ocean in its lower atmospheric layers, this life form could evolve into supercritical water bacteria. These bacteria could have developed different metabolic pathways to withstand pressure and temperature. While plants like Zea mays cannot withstand extremely high pressures on Earth, bacteria of the Thermococcus genus in deep-sea tubes can survive at temperatures up to 122 degrees. On K2-18b, despite higher pressures, these organisms could sustain their chemically powered lives. Some scientists believe that microscopic organisms could exist in the atmosphere even if there is no ocean. These aerobacteria are proposed based on examples of bacteria living in the cloud layers of Earth. If the cloud layer in the atmosphere of K2-18b is composed of liquid water droplets, it is possible for microorganisms to settle inside these droplets. In 2013, NASA researchers found terrestrial bacteria in Earth cloud samples, providing clues that life could exist in the atmosphere. A similar situation could occur on K2-18b. If the clouds in its atmosphere carry both water and organic nutrient particles, aerosol-based life forms could exist there. After 2025, the JWST will use instruments with much higher spectral resolution to search for molecules such as ozone, methane, and carbon dioxide in K2-18b's atmosphere. If we detect methane and ozone at the same time, this chemical imbalance could indicate biological processes. Methane and ozone are two molecules that chemically destroy each other. Their presence together could indicate a constant fresh source, such as living activity. In the next 10 to 15 years, we may see specialized space telescopes that break away from Earth and focus solely on studying K2-18b. These telescopes will be able to track trace gases in the atmosphere in real time, modeling daily or seasonal changes. This will allow us to gain insights into the planet's seasonal cycles or storm systems. Scientists are comparing K2-18b to other habitable zone planets. For example, some planets in the TRAPPIST-1 system are Earth-sized and share many similarities. However, the most significant difference with K2-18b is that it emits a clear water vapor signal. In previous discoveries, atmospheric content was often unclear or detected with very low confidence. At a distance of 124 light-years, sending a manned mission with current technology is nearly impossible. Even our fastest plans would take centuries. However, there is a vision for robotic exploration in the future. Signals will take hundreds of years to travel. Interruptions will limit communication with Earth. In the near future, we are designing very small, 4 cm square gram-scale nanosatellites. These satellites can be accelerated by solar sails to reach 20 to 30% of the speed of light. Thus, it would take approximately 500–600 years to reach 124 light-years. Though it may seem like a brilliant idea, this step alone will rewrite the history of technology. Perhaps we won't see it, but thanks to these projects, the next generation will decode data signals from K2-18b. Investing in this vision is the most valuable step we can take to bring the future into our hands. K2-18b is not just a planet, it is a gateway to infinity for human curiosity. If signs of life are detected in its atmosphere, we will have concrete evidence that we are not alone in the universe. The emergence of the basic building blocks of life in another universe could lead to the development of new theories in biology and chemistry. The widely accepted notion of single-origin evolution could be shaken, and the concept of parallel life forms might enter scientific literature. Space exploration inspires scientists and young generations. Every new discovery about K2-18b is a reason for a young person to say, "I want to be an astronaut." Perhaps one of us will owe the inspiration to develop the spaceship of the future to this news. Every viewer of this video takes one more step on the journey to unlocking the secrets of the universe. Who knows? Maybe your children will design the first manned mission to K2-18b. What matters is never limiting your imagination and always asking, is it possible? Thank you for watching. If this journey of discovery has inspired you, don't forget to like, subscribe, and turn on notifications. See you in the next video, and keep looking up at the sky. because there's so much more to discover, including more planets like K2-18b. Take care, and see you next time.